Okay, so let's start with the next exercise. This is multiple linear regression. This is for the wine quality, to check the wine quality, and the data set that we are going to use is wine quality dot csv. So let's start. Again, we have got this code already written and I have cleared all the processes. So here you can write it again, like title is given, these are all remarks. MLR1 wine quality dot csv for MLR. Linear regression with two variables is common, but all the real world problem that we are going to encounter will have more than two variables. Linear regression involving multiple variable is called multiple linear regression. When there are more than two variables, of course it is multi-linear regression or multivariate linear regression. The steps to perform multiple linear regression are almost similar to that we have seen earlier in the simple linear regression. The difference lies in the evaluation only. You can use it to find out which factor has the highest impact on the predicted output and how differently variables relate to each other. Now again we can run this. Nothing will happen. The data set related to red variants of the Portuguese vino verde. Now this is the name of the wine. This is the Portuguese wine, and due to the privacy and logistic issues, only physico-chemical inputs and the sensory, the outputs variables are available. They have not given the complete details. So whatever data is available, we are trying to use that. So for example, there is no data about the grape type, wine brand, wine selling price, etc. Again, that doesn't make any difference, because as far as we are concerned, we can only do our analysis. So again, for this we will take into account various input features like fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH value, sulfates, alcohol. So based on these features, we will predict the quality of the wine. Right? So again, we can run that. No issues. Again, now we have to import all the libraries as we have been doing, and this is a step which every time we have to do. So like again here we are importing pandas, numpy, matplotlib, seaborn, then sklearn, and then of course all those sub libraries are also required to be imported. So once to run that, we have to simply import it, we have to run that, and when we get it, then the data file that we have got, again it is the wine quality dot csv. Again it is residing in a particular path, and df is the data frame is equal to pd, the panda read underscore csv. So because it is a csv file, so that is what we are going to read. We are going to again run that so that the data is available in the memory that has come. Now we are going to check the shape of this particular data set. So we can do that by running this. So now we have got 1599, that means 1599 rows and 12 columns, right? This is the total matrix of the data. Now df head, the first 5 rows that we can see by running it. So you can see that the first 5 rows we have got as and all those variables, that is fixed acidity, volatility, citric acid, all that are available to us here, and these are the first top 5 records, right? Now df info is again, now this step I have always been saying that this step is very important, because this is a data exploratory step. So we are exploring the data. Why we are doing it? Because we must understand our data as closely as possible, and this can be done. So and all these steps that we are going, this has got nothing to do with the actual analysis as such, but these steps are only required to understand the data better. So that is why these steps are very much essential. Now we write this df.info. You will see that again some additional information will come, fixed acidity and non-null floated 64, all these additional information, and these information will definitely give you a very good idea about your data set. So you can go through all that, try to understand as much as you can, and the more you start working on it, you will start learning. Then describe. Here you are going to get all the statistical analysis, like the count, the mean, standard deviation, minimum 25 percentile, 50, 75 percentile, and maximum. All these things with all the variables that are available. Right? So this is how the data is available to you. Now let's clean our data little bit. So first check which are the columns, which column they contains which has nan values. Nan values means that what are those? In case there are name, then we have to see that these nan values should not be there, or something has to be done with that. That is what it is. So we will see in the data file which we are having here, but we are having only 5 records, so it may not have. So let's see. So we can run that. Now df is null dot any, that means we are trying to find out if any null values are there or not. So run, then you can get that fixed acidity false, volatile acidity false, like that. You are getting all such information just by writing this particular code. Now data set is equal to df fill na. The na means nan, that not a number. Method ff fill, and then you have to fill it with something. So let's run that, and nothing will come as a result, but certainly something has happened there inside. So once we run this also, once the above code is executed, all the columns should give false. In case for any column you find true result, then remove all the null values from that column using the above code. So we can see that just by doing that, everything is filled, nothing is left blank. Now we are going to have the histograms. So to get that, df hist bins is equal to 10, fixed size is 6,5, and plt show. Then density df plot kind density type, kind is density type, then subplots true, and layout and share false. And so with this you are going to get some, it is still in the process. So once it gets completed, you will see that you will get some group of plots. This is something like that, with different things like alcohol, chloride, citric acid. So whatever features that we have seen, all those variables that we have seen in our data earlier, like here, fixed acidity, volatile, citric acid, residual sugar, all these things. So with every variable you will get a kind of a graph. So a group of graphs are going to be available to you for this thing. So this again gives you a very good idea as to how this thing, and this is the density. Density means that every variable has some density, because your quality of wine will depend on the density of that particular variable that we are going to check here. Right? So all these things can be seen here in this type of graphs. So that is why this graph is very useful. Just by looking at the graph, and particularly those who are experts who understand this, the quality of the wines, etc., they can definitely draw their own conclusions as to how the quality is, which particular variable should be how much, and what is the type of what is the effect of this. All these things can be understood by those experts. Now we are going to create a kind of a correlation matrix, core matrix. Now here we can see what is going to happen just by writing this code. Core matrix, correlation matrix is equal to df, that correlation, and print correlation matrix, quality, sort values, ascending. So that is how you can see that just by reading the code you can make out something, and once you start practicing you will get to know everything. So once we run this, you can see that you will get like this kind of a values. Quality is this, alcohol is this much, sulfates is this much. This again is slightly technical in the sense that because we are not familiar with the quality of the wine, the details of that, so we may not be able to understand, but definitely it gives the kind of indication that what is the kind of values that are there for each of these variables which is there. Then we are going to, these are the columns, that the fixed acidity, volatile acidity, citric acid, and then of course other things like residual sugar, chlorides, then what else, free sulfur, sulfur dioxide, total sulfur dioxide, whatever features are there, all of them are there. And this we have to see that these are the different column names, because we have seen already there. So correlation matrix between correlation is equal to df dot correlation, that of course we can get the correlation between the two. Then figure AX plot subplots fixed size 10 by 10, and then generate the color map. Color map is equal to SNS. Now here we are going to have a heat map, because this type of a SNS as we have already given as seaborne as SNS, and SNS gives us the heat map. So diverging palette 220 by 10 as C map is equal to true. And then generate heat map, allow the annotations. Annotation means that you will also get the figure within every block, that what is the the intensity of that particular block, and place floats in a map. So SNS heat map correlations, C map is equal to color map, annote is equal to true, and format is 0.2f, that is 2 decimal points. And axis is set X tick labels, columns is equal to name, rotations is equal to 45, horizontal alignment is equal to right, and this is then AX is equal to set Y tick tables, column names, and then plot show. So when you write this code, you can go through again, try to understand, and you can the more number of times you keep on referring it, you will get to know more and more, you will understand more and more. So once we run it, you can see that you are going to get, again the process is still on. So once this process is complete, you will get this kind of a graph, which is a heat map. Now as I said that these are the various features that we have seen. All those fixed acidity, volatile acidity, citric acid, all those things will be there. Similarly on this side also you are going to get this, and these are various blocks which tells you the intensity of that. That is why the annotate here, if you this annotation is equal to true, which we have given, that means whatever value will be there, it is true, and so that is why it is printing there or getting displayed you there. And color map, color is already decided by itself, and these are the 2 decimal points. So you can see that 2 decimal points are available to you. So everything is as per the code that you have written. Only thing that we have to learn and practice, in fact, not learning of what you are doing, but you have to practice more and more, so that you know that when do you need what and how you can write that. That is something which is important. So this comes only with practice. So this is how you can get this. And these are again very informative. I mean, again, for the people who are kind of experts in this area, they will get to know, and they will definitely be able to have their own inferences from this. Then our next step is to divide the data into attributes and labels. X variable contains all the attributes, features, and Y variable contains all the labels. So now X data set is equal to this, all those fixed acidity, volatile acidity, citric acid, etc., etc. All those things you can see that they are here, and these are with the values. And Y data set is quality, because that is what we are going to check against, because all these factors are one, and then quality is to be checked for them. So once we run that, you can see that nothing will happen as such. Let's check the average value of the quality. Again, nothing will happen as such. Now we are going to plot a graph. Plot figure is equal to fixed size 15 by 10. Plot tight layout, seaborne instance dist plot, that is distribution plot. Data set is equal to quality. Now you are going to get another heat map, and this time you are going to get it something like this, which is going to give you that the variation in your data, that how the variation has taken place. So this gives you the quality, that where the quality is very good, where the quality is like the axis also shows the quality. So this shows that the quality here is very good, here is something lesser than that, and like that you will get it, right? So this is how you can get the graph for this. Again, a visualization, which is again very, very helpful. Then comes the, as we can see, observe that most of the time the value is either 5 or 6. Like here you can see that 5 or 6. Next we split 80% of the data to the training set, while 20% of the data to the test site using below code. Now again we are dividing our total data into 80 and 20, 80 for training and 20 for testing. Again the same type of code, x train, x test, y train, y test, train test split, x y, then test is equal to 0.2, that is test size is 0.2, that is 20%, random state is equal to 0, again no iteration. Now let's train our model. Again the same thing, regressor, linear regression, because it is again the linear regression type, but it is only multivariate. So we can run it, even this has to be run. We should not skip that. This can be run, then we have to transfer the data into training and testing. This can be run, this must be run in fact. Then again run, then here again we are running it, executing it, and you will get that the linear regression copy x true, fit intercept is equal to true, and job is equal to none, then formalize is false, right? Now here we are going to, in this case the multivariate linear regression, the regression model has to find the most optimal coefficient for all the attributes. To see what coefficients our regression model has chosen, execute the following script. So this of course for our information, so that we understand it better. Here again these are all remarks, so we can, and then correlation that we have to find out. So correlation is equal to df core, then quality, drop quality wherever it is not applicable, print correlations, and then we can run it. So you can see that you are going to get the correlations between fixed acidity, volatile acidity, all these things, and this is the way you are going to get the different values for the correlation, right? Now the next is to draw a heat map. Now we are going to draw a heat map and get a detailed diagram of correlation. Insert the below code. So again we can, this is again remark. Now we are going to draw a heat map. So import cborn as SNS heat map, df. Whatever correlation that we have got, on the basis of this we are going to draw a heat map. So for that simple code, once you run it, you will get that this kind of a heat map. And again whatever values that we have got there, on the basis of that we have got all these, So this again gives, here we have not given the annotation because it was not required. So but if you want you can give that also, it doesn't harm anything. But this is how you can get the heat map, which again is very informative, and you can definitely take your decisions. Now define a function, get features which output only those features whose correlation is above a threshold value. Now threshold value means that a cutoff value. So that we must know, passed on an input temperature to function. So again we can run it, nothing will happen. Now def get features correlation threshold, whatever threshold is there, absolute correlation, apps high correlation, apps, and then again apps correlation greater than correlation threshold, dot index dot values dot toList, return high correlation. And once we run this, you can see that again here, because it is all calculation, so nothing will happen. But here you can see that create vector x containing input features and y containing the quality variable. In x we get all the features except residual sugar, that the threshold value can be increased if you want it. Now this is again for our information. Now features that we are considering is again all those which were there. So we can run that and you will see that nothing is going to happen, because features will be transferred to this particular variable called features. Now here x data set features, all this has come here, so data set has been transferred here. Then y is equal to data set quality. So once you run it again, nothing will come as an output, but certainly the data gets internally stored in x and y. Now to check the correlation between different features on the heat map, we can again draw a kind of a heat map here. like here import seaborne as correlation, import matplotlib myplot, pyplot, sorry, figure plot subplots, fixed size 10, and SNS heat map correlation vary max square true, and annotation yes will be coming, and C map is equal to blue. That means the heat map will be coming in the blue color. And once we run it, then you can see that the process is right now on, and you are going to get a good heat map with annotation. That is, these are the values inside the blocks that you are getting, and these are all the features that we have taken into consideration there. So this is how you can get the heat map for this kind of a and the correlation between the two different data set. This is how you can get it. Now plotting pair plots with the help of seaborne to plot the regression seaborne different features and targets. So you can run this again, and again we are distributing the data x train, x test, y train, y test, train test split, x y random size is equal. Now here we are going to have 3 iteration because random state is given as 3. So we can run it. We can right now we are splitting the data, regressor fit, and then we are going to again run this. So you get the linear regression, copy x is equal to true, fit intercept is equal to true, and job is equal to none, normalize is equal to false. So once now you have got the all these calculations already done. Now we are going to finally run this accuracy part. So once you go for running this, because here all these based on all these factors, all these figures that we have got, we are going to get the accuracy part, and accuracy is equal to regressor dot score y test x test y test, and then accuracy is percentage, format is this into 100. So we get the accuracy as 38%. Now this is something which we as the expert, those who are the quality experts who can check the wine quality and say that whether this percentage is correct or not, that is for them to decide. But certainly we get these figures. So as far as the linear regression is concerned, it is very helpful. You can see that these kinds of, with the help of the libraries which are available and these kinds of graphs that we get, it is very easy for anybody to understand. Only thing that you should have the knowledge as to what are the codes, how to the code is to be written, and what are the kind of outputs that we are expecting. And accordingly you can write the code and you will get it. So you can see that it is something which is very, very useful, very handy, and very informative. Thank you.